You should have received an email just before the start of class. One of the problems in Chapter 4, Section 8 asks about an absolute maximum. We haven't covered that. That's earlier in Chapter 4, and I forgot to remove it from the problem list. Please do so. I will update the problem list on our Canvas page to pull it as well. But that means there are only 4 problems in that section instead of 5. What questions do you have for me about the homework from any of these sections or for the exam review, because the exam is Thursday? Yes, Jeff. Number 40? 41. 3.9, number 41. So we're looking at the length of the third side of a triangle as the two sides fixed and the angle between them is changing, right? So the first question I have is, what formula relates the side of a triangle to the angle opposite it? Especially when we know that angle is not a right angle. Two sides of a triangle have length 12 meters and 15 meters. The angle between them is increasing at 2 degrees a minute. How fast is the length of the third side increasing? So, I've drawn a crappy picture. I need an equation that relates the thing I want to know to the things that are changing. I have to dig back into my trig class for this, because there are rules that allow me to solve for triangles even when I don't have a right angle. Now, since in this case, I know the side, the angle, and the side, and the angle is between the two sides, I go, wait a minute, we talked about solving triangles. We had side, side, angle, we had angle, angle, side, we had side, angle, side, and we had all sides. This is the side. What rule goes with this kind of a triangle? The internet is your friend. If you do not have this memorized, that's okay.
I have this wrong, but like c squared equals a squared plus b squared minus 2ab cosine c.
This is the law of cosines. And when I've written it in this way, those labels should relate to the parts of this triangle. So what label here goes with what up here?
You have to label your sides first, so you have to set one side to A and one side to B, whatever.
But there are 3 sides, so tell me which one is which.
I set 12 equal to A. I set B equal to 15, and then I just labeled the third side C.
Aha. The important part of this equation is that the side opposite the angle we know is the side we're solving for. That also means that I now know the name for this angle. That angle matches that letter. That's why I've used a capital C. That's why I put serifs on it, so I know it was a capital. Because otherwise it's hard to tell a lowercase c from a capital C without lines. Great. I now have the equation I need that relates the things I want to the things I was given. There's only one other problem in this whole thing. And it's something that, as a math person, is a deep insult to me personally. I hate degrees.
We need to set the rate.
Degrees suck. We need it in radians. 60 degrees in radians is?
Pi over 3.
But I also need 2 degrees per minute to become radians per minute. So I have to do that same conversion factor here. Remember, what I'm doing is I'm multiplying by pi and dividing by 180 to get degrees out of the bottom and radians in the top. I need a calculus term. This is a change. Change in what? Say that again, Joy. Which means it's a derivative with respect to t. Derivative of what? Well, I don't have a theta anywhere in this picture. Capital C. Yep. So I can now say, oh, dc dt 2 degrees per minute becomes multiplied by pi divided by 180. And again, remember, technically, radians are unitless. Why I put it in parentheses there, it's per minute. There shouldn't be anything on top, but that looks weird. Jack, what are we trying to find? I don't have an x. Right. I want the derivative of little c. I have my equation. I need to take the derivative of all the stuff with respect to time. So, is A changing? That means this is a constant. Is B changing? Same thing. Derivative constant is? Yay! The only thing in this entire equation that is changing are the C's. So when I go to take my derivative, I need to leave the things that are changing as variables, but the things that are not changing can be replaced by their numerical values. We do have a value for capital C. Just can't use it yet. When you take your derivative, what do you get on the left-hand side?
dc over dt.
Well, good, there's the dc dt we wanted. Take the derivative on the right-hand side. Derivative cosine is? But there's already a negative here.
It's going to be positive side.
Up, it'd be positive all thing, right?
Yeah.
So 2 times 12 times 15 sine C. But wait, there's more. Chain rule. I need to take the derivative of everything that's changing. C itself is changing. This is my implicit derivative routine. So far, so good? Disgusting, isn't it? Please notice, on the right, I know C. I know dc dt. On the left, I want to find dc dt. I don't know C. How do I find this little c right here? Just one problem. Pythagoras only works when the angle is 90 degrees, and the angle here is not 90, which means I need the rule we were using in the first place to set this sucker up. Find C, I use this. Because I know A and B and capital C, I can plug in to find little c. Then I will have all my numbers, and I can solve for the one I don't know. The worst possible part of this problem is that I had to figure out which formula to use in the first place. Where the hell? Good thing I did law of cosines back in the trig class, however long ago that was, and your brains are going, I used to know that. I used to know that. I will point out to you, though, two important things. I Googled this problem. The very first answer that came up on Chegg is wrong in two different places. Be careful. I can tell you exactly who Googled this because I know what answer they get and I know where they screwed up. Don't do that, people. They make a very simple mistake. It's not a big mistake, but it is important. And they carry it the whole way through the problem. Better? Great. More questions? Yes, Leo.
My question here about like it was I think it was 310 number 10.
310, number 10. Verify the linear approximation and then determine where it is accurate to within 0.1. Okay. Verify the linear approximation is the easy part. Remember, our formula for the linear approximation is f of a plus f prime of a x minus a. So you take the derivative, you plug in 0, you take the function, you plug in 0, you put those numbers there. We should get 1 and 1. Remember that when you do the derivative, you have to do the product rule. Okay. Now, verify where this is accurate to 0.1. I want to know where the difference between these two is less than a tenth. Now, that's kind of hard to do algebraically. So I'm not going to do it algebraically. Graph the function L of x minus f of x. L of x minus f of x. Now, I only care about where this is between a y value of negative 0.1 and positive 0.1. So I really don't need huge y values on this. So I'm going to go in here and change the y values to be fairly small. And I'm pretty sure this is not going to happen for a huge range of x's because my linear approximation should only be good close to a. In this case, a is 0. So I don't think I need to be much bigger than negative 2 or 2 in the x direction. So I'll go up here and change that as well. With me so far? No?
Yes.
Graph it. Now, I want to know where this is between negative 0.1 and 0.1. This sounds an awful like what we did back in chapter 2, finding the deltas for the epsilons.
Yes.
So let's draw the horizontal lines at 0.1 and at negative 0.1 by graphing 0.1 and negative 0.1. And then what you need to find is where those things cross. which you can do completely on here. Second, calculate intersection. And you'll get two x values. And you'll be able to say that this linear approximation is close enough between whichever two x values you find. By the way, if you'd graphed f of x minus L of x, you get the same answer, it just looks the other direction. Leo, better?
Yeah.
Wonderful. Thank you. You had a question as well. Where is that problem? Which number?
4A.
4A. Use implicit derivative to find. Okay. Okay. Whenever I take the derivative of something that involves a y, I get a y prime. Whenever I take the derivative of something that involves both x and y, that's a product rule. So here, I take my derivative with respect to x everywhere. So the derivative of x squared is derivative of 2xy. There's a product rule. Derivative of 2x is a 2. Leave the y alone. The derivative of y is a y prime. Leave the 2x alone. Derivative of y cubed. Perfect. On the right-hand side, x squared, y squared is a product. Derivative of x squared is 2x. Leave the y squared alone. I'm going to run out of room here, so I'll put it underneath. Leave the x squared alone. Derivative of y squared is 2y, and my y prime. You have a choice to make for me. Do the y prime stuff go on the right or the left? Okay, means I need to move these terms to the right. I need to do the term without the y prime to the left. I simply rearranged the 2 in front of the x squared here so that it would go in descending order alphabetically, that all fun stuff. Make it look pretty, from my definition of pretty. On the right-hand side, factor out the y prime. And then divide to get y prime alone. Ta-da! It's both. Because every time I do the derivative of the y part, I need the chain rule. But when I do the derivative of just the x part, I only need the product rule part. In some textbooks, you will often see these terms put in parentheses to remind us that what we're doing is a product rule, and those came from the same piece in the line above. Better? Because I'm doing an implicit derivative, I always need the chain rule whenever I do the derivative of a y. Whenever I have multiple things multiplied together, I've got to do the product. More questions?
Could you do W of X?
W of x. So, e to the secant inverse garbage? Okay. All I want's the derivative, yes? I need my formula sheet. The one that's on our Canvas page, the one that's in the section in Canvas where the review sheet is, that has the trig and the inverse trig derivatives on it. Because I don't remember the derivative of the inverse secant off the top of my head. But I do know the derivative of e to the stuff is e to the stuff. And now the chain rule comes in play. Off the formula sheet, the derivative of the inverse secant. Now, let me make a little note off to the side, because the formula on the formula sheet is secant inverse of x. The derivative of secant inverse of x is, what's it say on the formula sheet?
1 over.
Great. But I am doing the derivative of secant inverse of 3x. Again, derivative of stuff. So wherever I see an x here, I'm going to put the 3x. But since that's stuff, there's another chain rule involved. It wasn't just secant of x, it's secant inverse of stuff, which means I need the derivative of stuff, which is derivative of 3x is 3. Perfect, I'm done. Did it say? Then walk away. I am perfectly happy to make you do lots and lots and lots of algebra if there's a purpose for it. This just said find a derivative. I found a derivative, I'm done. Walk away. Now, you could do quite a bit of simplifying on this. The 3 on top on the end will cancel the 3 in the denominator on the outside of the root. 3x quantity squared is 9x squared. But then I look under the square root and it's something minus something, which is the difference of 2 squares. Is that worth getting? I want to know that you can use the chain rule and you can use the formula sheet, and that's good enough. Better? Hit me again. The logarithmic differentiation. So the first thing I need to do is I need to take my equation and stick an ln into it. Y equals x raised to the tangent x power. So ln of y is ln x to the tangent x power. So far, so good? What do I do with the tangent x on the right-hand side? Properties of logarithms. Power inside gets yanked out front and multiplied. Because when you have a power of a power, you multiply those powers. Logarithm's another word for power. So a power of a power means multiply powers. Well, now, on the right, I have a product. On the left, I have an ln, implicit derivative time. Derivative of ln of y is 1 over y, but wait, there's more. On the right-hand side, I do the product rule. Derivative tangent, secant squared, leave the ln alone, leave the tangent alone, derivative of ln of x is 1 over x. My goal was to find dy dx alone. Just said find dy dx. Then I need to move the y to the other side and replace it with its expression in x. It's y times all that junk. Well, wait a minute. That's x to the tangent x times secant squared x ln x plus tangent x for x. I started with an explicit function. I have an explicit derivative when I finished, even though I used implicit in the middle. Better? Hoorah. More questions? Yes, Jeff. 4.8, number 20. So number 20 asks me to find all solutions of the equation correct to 6 decimal places. First thing I'm going to do is I'm going to graph this particular equation to see what's going on, right? ln of x 1 over x minus 3. Remember your parentheses when doing that because you want the whole quantity in the denominator. Under the bright light, you can't see it. Back to the standard window. Although I know ln of x only exists when x is bigger than 0, so I really only have to worry about this on the right-hand side. I see 2 intersections. One of them is over here, one of them is up there. So, if I were going to start this problem, I would say I probably want to start with one small x value and one larger x value. This looks like it's somewhere around 4, so maybe we start at x equals 4. This one is less than 1. So I would say we probably want to start around a half. Sound reasonable? I have starting values. I can crank my way through my formula for this, right? Newton's method. Xn is xn minus, and then it's the function on top and the derivative on the bottom. Remember, this is our linear approximation equation solved for the y value being 0. And the function I am using, because remember, I want to find where these two things intersect, means I want to find where the function's equal to 0. I write f of x is ln of x minus 1 over x minus 3. Or the other way around. You could do it 1 over x minus 3 minus ln of x. It's your call. Then f prime of x is derivative of ln of x. One over x. That's easier as a power with the chain rule. Write that as x minus 3 quantity to the negative 1, rather than doing the quotient rule. I told you I like the chain rule better. I don't want to do the quotient rule if I don't have to. Could. Negative times negative is positive. X minus 3 to the negative 2 times the derivative of the inside. The derivative of the inside is
No, 1, sorry.
1, the derivative of the x. Multiplying by 1 doesn't change anything. There's my derivative. Now I can start plugging and chugging, yes? Start with one of them. At a half and the other one at 4. And let her rip. It says accurate to 6 decimal places. Means you're going to keep going until 2 of your answers in a row have the same first 6 numbers after the decimal point. To that end, I think it is easiest on your calculator to do this from the home page rather than from the graph, because then you'll get at least 9 decimal places visible. On the calculator screen on the graph, you'll only see 6 decimal places. So again, personal opinion. But you can do it in either place. If I hit trace, 0.5, there's my y value. Second, calculate the derivative at 0.5, there's my derivative value. Which one's easier is up to you. But you'll notice this has got calculation round off issues. So it might actually be easier to do it from here. Better? More. Tom, did I see your hand up earlier?
Oh, yeah. 3.84A.
3.84A. Okay, so the bacteria culture is growing 400 after 2 hours, 25,600 after 6 hours. Okay, I know for a fact, because this is our growth model setup, that I'm going to use the equation that looks like this. Problem is, I don't know A, I don't know R. And 4A is asking me for R, relative growth rate. Now, since this is growing, I expect a number larger than 1. Positive growth rates, positive numbers. So, I need solve for A and solve for R. But I have 2 sets of times and 2 populations. So let's plug those in and write down that information. 400 is equal to A e to the R times 2. And 25,600 is equal to A e to the R times 6. Ew. All right, the reason this is unpleasant is that my first reaction is I haven't the foggiest idea how to get R out from the other things, or A out from the other things. So pick one of the equations and let's solve for A. Okay, so if I want to get A all alone here, I would get that, right? Now let's put that A into the other equation. Hey, wait a second. I have 2 E's, right? They're being divided. What do I do when I divide things with the same base? So that makes this right-hand side e to the what power? Which means I now have one equation with only one variable in it. Since the thing I wanted to solve for was R, I can get that right from here. You're welcome. Once you have R, though, you can find A. I think part B says, what's the initial population, the initial size of the culture? That's our A value when time is 0. Sneaky little mothers. In all of the other problems we did, in every single one of them, I gave you the information of what was going on at time 0. And then in this problem, they didn't. Rude. Beep. Okay, I feel better. More questions.
Number 12.
4.8, number 12. Approximate the number correct to 8 decimal places. The 8th root of 500. Bleh. Okay. If I want the 8th root of 500, let's call that x. Well, then what I'm really asking you to do is to solve that equation, which is the same as trying to figure out where that's equal to 0. Eighth powers. I'm looking at 8th powers. This should be close to an 8th power, I know. 1 to the 8th is 1. What's 2 to the 8th? 2, 4, 8, 16, 32, 64, 128 is 2 to the 7th. 2 to the 8th is 256, right? Okay, that's not quite close. What's 3 to the 8th? Much further away, isn't it? I think we better start with 2 then. And we can get closer and closer and closer to 500 with an x0 of 2. Interesting enough, my brain went, 500 is pretty close to a power of 2, isn't it? Because 512 is 2 to the 9th. Damn. Would have been so much better if this was a 9th root. Oh well. We'll start with 2 and crank it out from there. It says do it to 8 decimal places. So you're going to keep going until you have 2 numbers in a row that are correct to at least 8 decimal places across the front. And again, this is my f of x. So f prime of x is pretty easy. I will freely admit it is possible that Newton's method will take a large number of steps. I don't believe you have to go more than 6 or 7 to get this to within like 8 or 9 decimal places. This is pretty quick. And the reason it's pretty quick is because this is fairly large when x is close to 2. So we diminish our change frequently. Now you can actually graph this on your calculator, figure out what the number is off the calculator, so you know if you're getting close to the right answer, if you're blowing up in the wrong direction. Easy thing to notice, if you make a sign error or something and all of a sudden your numbers start bouncing the other way, that's not necessarily a bad thing as long as they are still getting closer to the correct answer. You get larger and smaller and larger and smaller, as long as you still narrow in. But this particular function, we should just be going in from one side. This is not short. More questions. Ask me more things. Yes, ma'am.
Could you do 9B on the review?
9B on the review.
You can just do the data, obviously it takes seconds to look at it.
Once again, I'm going to say I'm very happy to try not to simplify. But I'm probably going to have to simplify in the first and second derivatives to make the third one easier. So let's see, 9b. G of x is ln 3x squared plus 5x. My first derivative. The derivative of ln of x is, but this is ln of stuff, so it's 1 over stuff. But wait, there's more. Which really makes this a quotient. Oh well. I guess I got to do the quotient rule now. Once I do the quotient rule once, for the next derivative, I'm going to end up with another quotient because I'll end up derivative of the top times the bottom, derivative of the bottom times the top, over the bottom squared, and end up with a second quotient here. Derivative of the top times the bottom minus derivative of the bottom times the top. The top is the same thing. Over the bottom squared. Were this any other problem, I would stop right here. But I want another derivative, so I better do the algebra to make this next quotient rule easier. 18x squared plus 30x minus 36x squared. 5 times 6 is 30, 5 times 6 is 30, 60x plus 25. So, x squared minus, so 18 minus 36 is minus 18. 30 minus 60 is minus 30, minus a 25. I'm not going to bother to try and factor that. I'm going to leave it just like that. But now it wants another derivative. I'm very happy that this is where I can stop because I'm going to take this derivative and not simplify a damn thing. The third derivative, derivative of the top times the bottom minus, leave the top alone, take the derivative of the bottom. I'm going to run out of room, so this is going to go slightly underneath, but it should be on the same line. The bottom is stuff squared. I need the chain rule. 2 stuff to the first times the derivative of the stuff. over the bottom, it's already squared. I got to square it again. Bleh. So this is really, are you proficient in quotient rule? And is there enough algebra here to make it worthwhile? That's disgusting. There are, of course, several other options. You could have tried to factor the numerator. Pull out the minus sign up there on top. I'm not sure any of that is worth it. But, you know, compare this to 9a, where we had to do a bunch of product rule and trig derivatives. I'm not sure which one was quote unquote easier. If you like quotient rule, this is easy. If you like doing trig derivatives because you have the formula sheet, that's your call. Then I think the first one would be easier. But again, it's going to depend on you. You will turn in all of this homework on Wednesday. At the end of class on Wednesday, I will post all the keys, including the keys to the review sheet. I do not know when a review session is being held at the Enrichment Center. I heard talk about it before break, but I have not heard anything since. I did not get a Penji announcement. Did anybody get a Penji announcement? There was one? Okay, good. Then good luck, Godspeed. I will see you all on Wednesday. Have a wonderful rest of your day.